we could record this class. Okay, like I said, it's the first one also about transformation. Let me see if I can. Okay. Right, we talk about transformation in 661. In this 673, you are going to deal with multivariates a lot of times. Okay, but don't be afraid. I mean, just that by principle, they are the same. Taking more time to derive the answers for sure. Okay, but just be patient. Just by, you know, sometimes derivation is like Zen things, right? You calm down and then you'll do better job. If you like too much like just, you know, if you feel like too much pressure, and then you possibly not going to do a better job. Okay, so like I said, it's taking time, just taking time. I will give you time to finish. If you feel like you need extra time to finish the homework, for example. Okay, good. So remember to talk about G function in a 661. Right now, it's not only about like a single function to do transformation. It's actually from 1 to k. H1 to hk. H is a function via transformation. Okay, and then we open subset, right, in RK. It's a k dimensional in a real line. Okay, good. If I suppose that it's h function right here is continuous, okay, we always talk about continuous function transformation. Okay, you're asking how about discrete function? You could, but nothing commonly application. In the common application, we see continuous more often than discrete. Okay, especially, you know, it's a smooth function. If you understand what I'm saying. Okay, and then with your first partial derivative in B, which means if I take differentiation on any single dimension, the first derivative is always exist. Okay, good. And then h function is 1 to 1 on B. 1 to 1 means I have one element x, one element y, and then vice versa, called 1 to 1 transformation. Okay, so if you don't understand this, or it's the first time to see so-called 1 to 1 function, okay, then you will possibly need to Google it to see what that is, and it gives a sense of mathematics. Okay, if you really just struggling, come to me, then I will use my language to see if I can teach you that kind of things more easy way. What does the 1 to 1 means? Also, or what does the one to many mean? Something like that. Okay, and then Jacobian, you guys know that, right? Okay, second derivative of any function called Jacobian. Okay, so then does not vanish on B. That means the Jacobian is not 0. Okay, good. So
I'm sorry, I have a quick question.
Yeah, go ahead.
When you write like h equals h1 to hk, is this like, is it a function from R to RK?
Yep.
Okay.
Oh no, hold on a little bit. Not necessary. H function is from RK to something.
It's from B.
Yeah.
I guess, like, is each I a function from B to R?
Yeah. So B, so RK is k dimensional, right? Then each dimension have a transformation to some certain to certain sample space, and then to that sample space, not necessarily only k dimension. It's not necessarily k to k transformation.
But it's like,
but it's from k for sure. It could from k to constant to single dimension.
But like when you write like h sub 1, h sub 1 is a function mapping from B to R. Is that right?
Yes. Yeah, I would say so. But you only talk about marginal, right? So it could be it's your h function eventually come down to single dimension. It could be. Okay, I'm not necessarily restrict to K to K transformation. Making sense?
Yeah.
Okay, yeah. Okay, so that's exactly how difficult it's for me to come with this class. Okay, because in the first class in 661, I don't even talk about what does that transformation look like yet. Okay, but I have to told you right here, I have to go right straight forward. I would straightforwardly to talk about less. Okay, you might hear me talk about this the same thing on Thursday as well. Okay, but eventually two classes is going to be separated a little bit in the concept. Okay, but first class I have no choice. I just told you that it's what transformation actually is. So X continues. Okay, and then S will be open subset of RK. Okay, then of course I only talking about the sample in a sample space. I'm not talking about something real case. Okay, so then if I talking about G1 to GK as a transformation from S to RK right here, RK right here, that means I do like a 1-to-1, right? I have K transformation. The outcome, the average transformation also K dimensional. If that's the case, then I can write a new PDF or actually new join PDF if I only say specifically, but sometimes I can know that join PDF, join term. Okay. A new PDF is going to be old PDF. Okay, then plug in the inverse function of the transformation. And then having an extra term of Jacobian. But Jacobian is going to deriving from multi-dimensional Jacobian. Okay, so in the 661, you'll see me just saying this, well, Y is a new PDF. Then writing down as X as OPDF. Then writing that inverse function, plug in of inverse function. Then within that as a Jacobian. That's easier life of master students. You guys are PhD students. You guys live in, more difficult life right here. You're working on multi-dimensional. Okay, but number one is how to find inverse function, right? I don't know how good you guys as undergraduate math class would be. To me, when I'm undergraduate, finding inverse function is a nightmare. Okay, but well, statistic is not difficult math. So imagine that it's statistic will only deal with something easy for you to find inverse function. Okay, we are not mathematician. We're using math as a tool. We are not that we don't have to be that difficult to find something for us to apply the mathematical science. So inverse function is a nightmare, but as you can see example, it's not that bad. Okay, then deriving a Jacobian. Okay, under multi-dimensional, you really need to be patient. All I can say is that. For example, right here, okay, if I only deal with two-dimensional, x1, x2 are independent random variables, and the x1, x2 both follow suppose standard normal distribution, which is x1 follow normal 0, 1, then x2 follow normal 0, 1 as well. So when we talk about standard normal distribution, automatically means it's normal 0, 1. Got it? Okay, then we are trying to write so-called joint density function of x, y1, y2, where y1 divided this way, y2 divided by this way, right? Eventually, we are trying to find it. Hey, can I deriving y1, y2's joint PDF? Okay, by these slides, right? This guy right here is actually y1, y2's joint PDF. Again, using exactly the same principle. You write it, okay, old new join PDF is going to be write down the old join PDF x1, x2 right here. Okay, and then you actually find inverse function because they are two guys. I do have two inverse function. Okay, that's exactly what I write here, right? Inverse function plugin, right? I have x1 slot, I have x1 slot, I have x2 slot right here. Okay, then what's that? By Jacobian. Yes. By principle, it's the same thing. Okay, but in this question, it's a real one. The real answer is the real one is what? Normally, when you do inverse function, right? I normally teach students, hey, just write it, right? So y1 equals to x1 squared plus x2 squared. y2 equals to x1 divided by x2. Okay. Then how do I find inverse function? Hey, it's actually easy. Do your best. Trying to write x1 and x2 in the left hand side, and then find that equation right here. Trying to put everything y1 and y2 in the right hand side right here. That's inverse function. But look at this. Look at this right here. Could you actually find out x1 and x2 in the left hand side? You have the x1 squared and x2 squared in the y1 right here. I think your life will become more difficult if you do that. Okay. Then, well, but it's a trick. Then what's the trick then? The trick is this. I'm not actually dealing with, I don't actually deal with x1, x2 itself. Okay. Hopefully, it's become bigger right now. You can see what's going on. Okay. Say if right here, like right here, right? So if this kind of things kind of easy, then if I sort of switch my head a little bit, if I say, if I can define u1 as x1 squared, and then u2 as x2 squared, okay? First of all, it's, do I know what u1 follows and what u2 follows? Right? Yeah, I do know that. We talk about it in 661. If x1, x2 are uniform 0, 1, u1 is going to become chi-square 1, u2 is become chi-square 1. Okay? That means I do know the joint PDF of u1 and the u2. u1 and u2. I can write it. Although complicated, but I can write it because I do know they're dependent, right? So I do know u1, sorry, where's my eraser? It's right here. Right here. Okay. I do know u1, so okay. How do I get disappear? This one? No. Okay. Right here. Yeah, maybe I just forget. I'm struggling to make it disappear, but it'll be fine. Oh no. So I think that u1 is what? Chi-square 1. So something we can learn right here. Chi-square 1 is basically is a gamma. Gamma what? Chi-square 1. Alpha is half, right? And then 2. Alpha beta. Yeah, I think so. If I remember correctly. So gamma distribution, PDF is going to be gamma alpha. Yeah, gamma alpha half, beta with alpha then 1 right here, and then I really don't need large. Take out something. PDF would be x as u1, u1 it, u1 x alpha minus 1, and then exponential minus x divided by beta. Beta is 2. Yep. This is a PDF of the chi-square 1 it. Sorry, let me figure out how to get my yeah, I think yes, got it. Okay, take out this. Yep. Okay, good. So that means I can write join PDF. Yeah. Okay, I can write join PDF of a U1 and U2 bits. Okay, if I can switch my head about, I'm using U1 U2. Okay, so right here, if I say y1 equals to square root of x1 squared plus x2 squared, I could basically say this guy, it's u1 plus u2, right? And then if y2 equals to x1 divided by x2, right? So right now I could have what? Hold on a bit. Y1 squared equals to x1 squared plus x2 squared. That will become, and then I will know y1 squared equals to u1 plus u2. Okay, and then implies y1 squared equals to u1 plus u2. Okay, and then I also from y1 y2 equals this guy right here, I can still y2 squared equals to x1 squared divided by x2 squared will become u1 divided by u2. Okay, good. So right here it's, I got it what I'm asking it. Let me go back a little bit right here. Okay, so although I'm saying it's, let's deal with join PDF of y and y2 right here. But actually, I don't think I can derive in the joint PDF of y or y2 bits. Instead, the question nice enough, the only asking about are y1 and y2 independent. Okay, so solving the statistical questions, you're always asking yourself, what's the first step, right? So if I'm asking you, how do I show y1 and y2 are independent? It's always like saying is what? You have showing what? Y1 and Y2 as a joint PDF. If I can write that as what? Product of marginal PDF, it's then using, if I can derive this equation right here, if I show this equation right here, it implies what? Y1 and Y2 are independent, right? That's possibly the first step. You would think whenever you like solving the problems in the exam, in the qualified exam or master exam, right? If you are trying to show some two random variable independent, you possibly will show this guy as a first hand, right? Right here, tricky part is I having transformation as complicated as y and y2 is. Okay, I don't think I'm going to deal with y and y2. Instead, I'm going to deal with y1 squared and y2 squared. How about that? Okay. Then again, it's, I would say, well, I possibly won't be able to deriving y1 and y2 joint PDF. Instead, hey, how about deriving y1 squared and then y2 squared joint PDF? If I do that, if somehow I call it actually V1 right here in later on, so if somehow I can say, hey, if V1 is y1 squared, V2 is y2 squared, if I can do less, right? If I can somehow show that V1, then V2, V2 is. If I can somehow show that right here, that would tell me V1 independent with V2, V1 independent with V2, V1 independent with V2, and also tell me that is Y1 square independent with Y2 square. That also implies implying Y1 independent with Y2 bits. Okay, good. So that means you get started, you see the path, you are trying to show this. Okay, good. Then right here, if I do switching everything, like right here, Y1 square, Y2 square right here, if I switch everything, eventually is what? V1 equals to U1 plus U2. Let me go back to see if that's the case. Yep. And then V2 equals to U1 divided by U2. Right? And then I said, find the inverse functions, nothing but writing your U1 and the U2 in the left-hand side of the equation. That's easy, right? You see right here. How do I make it as a V1 and V2 in the right-hand side equation? Easy, right? So right here, U1 is what? U1 is V1 minus U2, okay? Of course, I cannot write V1 right here. Oh, of course, I'm sorry. Of course, I cannot write U2 in the right-hand side because I say your right-hand side to be V1, V2. This guy is, oh no. Okay, this guy is U1, U2, then taking out. So it become from here, right? From here, I do know U1, hold on. U1 is V2, either way. So from here, U1 is V1 minus U2, right? I cannot keep U2 in the right-hand side. I have to switch. Hold on, did I? X2 square, X1 square, X1 square, U1, U2. I don't like it. So U1 is V1 minus U2. U2 is, yeah, I don't like it. So let's do another thing. Let's keep taking out right hand side right here. I like it better as U1, it's V2. It's a V2, U1 is a V2 times U2 from this equation right here. Right, U1 is V2 times U2. And then U2 is what? So V1 hold on, V1 is U2. Okay, it looks like it's not as easy as I think. So U1 is V2 times U2, and then V2 times U2 it's V1 minus U1. I'm getting a circle right now, right? So let's solving for linear equation then. So V2 equals to V1 minus U2 divided by U2. So then, let me take out everything right here. So give me things more clear about. So V2 is, I like V2, U1 equals to V2 times U2. If I do that, V1 equals to V2 U2 plus U2. So that means U2 would be 1 plus V2. Okay, so that means I isolate U2, which I like, which is V1 divided by 1 plus V2. You guys with me? Okay, I cannot see you, so I don't know if you can follow me or not. Okay, by any means, try your best to make a U1, U2 in the left-hand side, V1, V2 in the right-hand side. So of course, this guy is not right. Okay, I think I I think I get the U2 correctly, right? The making double check. U1 it's V1, V2, U2, and V1 equals to, right. I think I got U2 correctly. Then I can just plug in right here to get my U1 because U1 is V2 times U2. So V2 times U2. Okay, so you could write the V1, V2 divided 1 plus V2, right, in the right hand side. Okay, so try to your best to deriving right hand side of U1 and V1 and V2 is. Then you follow principle. So which means I trying to deriving a joint PDF of V1 and V2. V1 and V2. Okay. And then you told me that, okay, it got to coming from the old PDF. All PDF would be U1 and U2 it's. Make sure on that. Yep, I think so. Okay, right here. Good. Okay, so then transformation, nothing but plug in. So this is my new PDF. This is my old PDF. Then plug inverse function, U1 equals to V1, V2 divided by 1 plus V2. Plug in. Then U2 equals to V1 divided by 1 plus V2x. Okay? Everything follow the principle. I told you, plug inverse function, but most difficult part would be what? This guy, don't forget about Jacobian. What does a Jacobian means right here? Right? 2 by 2 transformation. Your Jacobian going to be 2 by 2 matches. And then you write it down, the matrix, then deriving the determinant of the matrix is called Jacobian. Right now. Okay, so what is a Jacobian right here then? It's really nothing but partial U1, partial V1. Then either way, people learn things differently. I usually using partial U1 and then partial V2. Okay, if you learn about this guy should be partial U1, partial V2, it's fine. I mean, they are symmetric matrix. It doesn't matter which one, which way. Okay, I just used to writing down as a partial U1, partial V1, partial U1, partial V2. Then if I write that way, then the second row would be partial U2, partial V2. Partial U1, partial V2. Partial U1, partial U1, then partial V2. Then partial U2, partial V2x. Hold on, partial U1, U1, U2, U2, and the V1 right here. Okay, first row is U1, V1, V2, U2, V1, U2, V2x. Okay, that's a Jacobian I'm looking for. Then because you do have that transformation right here, right? Okay, then it's nothing but working on that partial U1, partial V1 then. So I don't know if I want to go to detail. Let me see if it's easy. If not easy, then we could go to the answer directly. So right here is partial U1 and partial V1, right? Look at this guy right here. Right, if partial U1, partial V1 become what? I think it's easy. Become V2 divided by 1 plus V2. Right, this guy right here, right? This guy is constant for partial. Okay, so that means you write it down as V2 divided by 1 plus V2x. Okay, then partial U1, partial V2. Look at this right here. You will see that it's what? Oh, it's too much. Oops, that's too much. So 1 plus V2. right? V1 and V2 right here. Then it's not hard to see that if I partial V2, oh no, it's not easy then. So then right here, I need to write it down in different ways because it does taking time to do that deriving partial about right here. If I really working on partial U1 and a partial V2, it if like a partial, right? V1, V2 divided by 1 plus V2 right here. Then partial V2 right here. Okay. You do have V1 as a constant for sure, but this guy right here involving the ratio, so it's not that easy to deriving the partial of the V2. It's right because this guy are ratio right here. You know that, right? In calculus class. I taking time for me to go on to do that partial right here. Let's just be lazy. Go to the slides and then to see what is the partial V1 divided by partial V2. Right here, it's 1 plus V2, 1 over V2. It's okay. And then right here, partial U2, partial V1. Wait. Oh, no, it's not symmetric matrix. What I'm talking about, right? So then, again, this guy right here is a partial U2, partial V1. Partial U2, partial V1 is easy. Yeah, it's just symmetric matrix. This guy is typo. Forget about it. It's still 1 divided by 1 plus V2. Partial U2, partial V1, right? 1 divided by 1 plus V2. That guy is wrong, it's typo. Then, again, this guy right here is partial U2, partial V2. Sorry, I lost my voice. Sorry. Yeah. Teaching on Tuesday afternoon is really tough. I have to speak for so many hours. So sometimes my voice are breaking. So again, right here, partial U2, partial V2. This guy also need to involving, but that one is much easier to handle, right? So look at V1 is, you could say 1 V1 times 1 plus V2, the inverse, right? The inverse is easy then. So that means, well, that guy could be also easy as well. That means this guy is nothing but inverse 1, then 1 plus V2, then inverse 2, then having chain rule as invert, the positive 1 then. Okay. So really, like as you can see, although principle are the same, derivation just so much lengthy in terms of in like a multivariate situation. So right here is 1 plus V2, and then this guy right here, it's minus V1, then 1 plus V2, then square right here. Okay, and then you guys remember how to do determinant of a 2x2 matrix, right? I assuming you guys know that. Then right here is nothing but this guy times this guy, and then minus this guy times that guy. Okay, so you work on it, and then eventually don't forget about Jacobian right here. It's always positive. Imagine Jacobian got to be positive, otherwise, like I say right here, right? If your Jacobian is not positive, what happens? Your PDF becomes negative. Did you ever see negative PDF? No, right? Good. So that means if you do that kind of crossing product, it turns out to be, if this guy is negative in some way, you figure out it's negative, then put absolute value on that negative value to become positive. So that means eventually this term right here is exactly doing that first directive in the Jacobian, but eventually put an absolute value to make sure that it's a positive. Okay, so I will skip that because I think you guys can handle, and then eventually I should take in the answer right here become V1 divided by 1 plus V2 then square as a determinant, as a Jacobian. So that means, okay, I have everything I'm looking for right now. I have inverse function, I have Jacobian, so let's keep working on. Let's keep working on to finalize right here, right? So new PDF, what I'm looking for. New PDF, what I'm looking for. Okay, new PDF, what I'm looking for. And then OPDF, I have inverse function plugin, and I deriving my Jacobian right here. Then the next one will be just finish, right? So let me take out a lot of things to give me a space to write down the final one. Okay, so that means my ultimate goal is trying to deriving V1 and then V2, then V1 and then V2, right? And then, although I didn't writing down join PDF U1 and U2, but keep in mind U1 and U2 are independent, so I can write as a U1, then V1, V2 divided by 1 plus V2 times U2, V1 divided by 1 plus V2. You guys with me? So although I run join PDF right here, because U1, U2 are independent, so I can write product of the marginal PDF. Then I putting down my Jacobian right here, and this is what happened. Okay? So then you're having the right direction. Okay, you keep thinking, I'm eventually trying to prove this guy is some kind of separation of some kind of product of two PDF. So this is my goal, right? This is my goal. Okay, good. So then from here is what? Like I said previously, I do know U1 and the U2's PDF right here, right? Then it's nothing but plugging, isn't it? So hopefully I can catch that. So because it's a long way to go. So if I plug in I do know U1, U2 are chi-square. So this is chi-square. So this guy is what? X alpha minus 1. So X alpha minus 1. So that means I plug in X. V1, V2, 1 plus V2. Okay, this is X alpha minus 1. Then this guy right here is exponential minus then X divided by beta. So that means this guy is X, it's V1, V2, 1 plus V2. Then divided by beta. Beta is 2 right here. Okay, and then that's only for V1 and then times, right? Again, U2 is chi-square, and then you plug in, right? Plug in right here, right? Plug in V1, then 1 plus V2 minus half. Then exponential minus 2 V1, 1 plus V2 is. Okay? I'll give you a second to imagine what I'm doing right now. Okay? So really, I take in the form of PDF of U1 chi-square, U2 chi-square, right? Form of PDF. then plug in where the x supposed to be, right? This guy's x alpha minus 1 is a Gauss distribution. So this alpha minus 1 become minus half. It's come out chi-square 1 is. Right, this guy's x, this guy's x as well. Okay, nothing but plug in where the x should be. Okay, and then eventually, hold on, I lost my power, so I need to plug in. Good. So don't forget about Jacobian. V1 1 plus V2 then square it. Okay, good. So here's something you want to learn in this class, and that will be useful for your homework as well. This is my goal, right? My goal is trying to find product of two PDF in order to show the independence of V1 and V2, right? And then you look at whole thing right here is what? Function of V1 and V2, right? Everything look at in the right hand side over V1, V2, V1, V1, V2, V1, V2, right? All about function of V1, V2 on the right hand side. Okay, but your goal is clear. I won't have like a V1 and a V2 product together. How to show that? Which is you pull your V1 together as hard as possible. Okay, that means where's my V1 is? Right here. These are constants. These are constants. There's some V1, V2. It's actually important. You could write C right here. Constant right here. Okay. Then you are going to catch those V1s. Okay. For example, right here, it's this guy have V1, this guy have V1, this guy have V1, right? Then I'm going to pull V1 together and see what happens. So it needs some, for example, it needs some time, some skill to make it happen. For example, right here is this guy, right? It's 1 alpha minus 1. Make sure I understand. Yeah, okay. Inverse, right? Okay, so that means V1 minus half become minus 1, right? And then V2, then minus half right here. I'm trying to combine this guy and this guy together, right? Make sure I don't make a mistake. And then this guy also have V1 as well to see that if I can first simplify and then V1 as well. Okay, then good thing happens. You know what? This guy V1, this guy V1 inverse cancel out. So it means the remaining terms doesn't have a V1. That's exactly what you're looking for. Okay, that means only a function of V2, right? Good. And then, of course, you can further simplify right here in the denominator. We can leave it there. And how about exponential then? Right? Exponential means you add this guy together, right? Okay. So let me write something much easier to write in exponential. It's exponential right here. Okay. Right here. Okay. So that means I actually doing is what? V1, V2, 1 minus V2, and then minus half V1 divided by 1 plus V2 right here. Okay, good. And then it turns out to be what? It turns out to be exponential. It's minus this guy, right? I can pull to a denominator. I can pull as what? 1 plus V2 right here. And then I can pull out V1, right? I can pull out V1 actually, and then 1 plus V2. Or V2 plus 1, actually much more straightforward for you to see. I don't want to confuse you. So V2 plus 1. Got it? Still with me? Hopefully. And then good thing happen again. 3 o'clock already. Give me some minutes. I want to finish this. Okay, so cancel out. This guy eventually only become exponential minus V1 and the 2. Okay, So that means you actually reach your goal because the first part by simplified equation, this guy only function of V2. Then the second part, this guy only function of V1. You got it. Okay. So let me say one more. Give me 1 more minute. I want to say that it's okay. So although I said I want to show that V1 and V2, if I can show that it's a marginal product of marginal PDF. Yes, if they are PDFs, you got the independence. The point is, right now, do I got a PDF? Not yet. I only have is one function that's a V1 and then one function of V2. Could I still claim that as independence? The answer is yes. Okay, but that's because I can always standardize my G1 and G2 become two PDFs. I will show Julia next week. Next Tuesday. To see this guy function of V2, how do I standardize it to become a common PDF form? And then this guy is a V1, how do I standardize it to become common form of V2 in terms of PDF function? Got it? Okay, so let's stop here. Sorry to 2 minutes over, about 3 o'clock. This is the life you're going to live with in semester. Okay, like or not, right? You need to taking time, be patient, line by line, but principle doesn't change. Just be more just the derivation be more complicated. Okay, and then you will see another example next week, and to see how to deal with n by n transformation. Again, still inverse function, Jacobian, but inverse function much harder to find. Jacobian is much harder to find. That's maybe the easy answer about what's the difference between 673 and 661. Okay, any questions? Wow, we got 18 people. Do we have so many? Okay. Yeah. Okay, so I will stop here and then I'll keep it on. You are more than welcome. Just unmute yourself and then ask me any question you are looking for, even in general. Nothing come to your mind, for example. You could ask me anything, like why do I need to learn difficult statistical theory, which I will never use in my future, something like that. I don't know. Okay, so let me see what else is typical. Let me think about what typical questions guys would have. Yeah, this I cannot think of any. Right. Okay. There won't be any question in homework coming from Biko and Dachshund. Okay. Typically, I will give you my own. I was looking for like a Gene Shaw's book. I was looking for other resources of mathematical statistic in the market. I would choose something I like. In homework. Pico and Dachshund's homework is really hard to solve in some sense. He sometimes is proposing two general questions. I think it's not really good as an introduction about the theory. So I normally don't pick Pico and Dachshund's book. Okay, so I think every question is coming from my own research of our resources. I'm not a smart guy, so I'm not going to create my own questions. That's for sure. So proposing questions is very hard in statistics. I've told you, it's not like, well, I can sit in here and then, some question popping out in my head, and I could give it to you. It's not that easy. So if you're asking me, could I Google it? Yeah, maybe you can Google it, depending on how good as you Google it. Nobody knows, right? Google is so amazing right now. So you guys do know that you could literally type in Google integral of some function, right? You guys know that? You could type in the integral of some function, and Google tell you what the value is. For example, if you type in integral of exponential x dx, you could type it. Google told you that's the value of integral of exponential x dx is. So, which means it's, if you really put my whole questions in Google, they would tell you where the book kind of come from. It could be possible. You could try. Okay, I don't want to bother you too long because I have my life to live with as well. So, okay, again, I'm quite accessible when, especially online teaching. Sometimes I feel I'm a YouTuber, right? Talking to you from a monitor, and then I usually evaluate students' take of my class eye by eye, eye to eye. So I cannot see you right now, so I don't know how much of the material you can take right now. But again, it's, if you feel like you want to know something, and then what I say is quite confusing, let me know. I can use another way to approach the questions you are interested, to see if that gets you more clear about the concept of the statistics. Okay, let me see chat box. Nothing in chat box. Okay, so anyway, I hope you enjoy this class this semester. So I always say that it's you working with me to grind it out. The grinding out sometimes not a good term, right? So, but I hope you have their willingness to grind it out. That's it. Okay. I will see you guys on Thursday. You guys have a good one. Bye bye now.